Now for the last group of proteobacteria, the epsilon proteobacteria. Epsilon proteobacteria have a tendency to be helical, like this example here, Campylobacter jejuni. Campylobacter jejuni, it's become one of the more common forms of food poisoning. Here's another one that's not quite so twisty as this one, but you can still see that it's a bacilli that has a tendency to form a helix. And this one is called Helicobacter pylori, and it is the causative agent of most ulcers. It likes to live in a low oxygen environment like you would find in the stomach, and it is able to neutralize stomach acid. So it's able to live in the stomach very nicely. Now, lest you think that all gram-negative bacteria are in the proteobacteria group, we're going to cover three other groups: the chlamydias, the spirochetes, and the bacteroides. Chlamydias are obligate intracellular parasites, like the rickettsia, but remember, rickettsia are alpha proteobacteria, whereas chlamydias have their own group. Now, they're obligate intracellular parasites because they can't make enough of their own ATP to survive, so they have to live inside other cells to be able to get the ATP that they need. Because of this, we have to grow them like viruses, grow them in living cells. And there are two examples of this group that I want you to be familiar with. Chlamydia trachomatis is the most common form of bacterial STDs, or sexually transmitted diseases, in the United States. It causes very few symptoms and signs, so a lot of times the affected individual doesn't know that they've got it, and so they can pass it to all sorts of other people. But it causes inflammatory pelvic disease, so you want to make sure that you don't leave this type of disease untreated. In other parts of the world, Chlamydia trachomatis causes eye infections, causes a type of conjunctivitis or pink eye, and flies transmit it from affected individual to infected individual, and this can cause blindness. We've been able to wipe that form of it out in the United States, but it still shows up in places that don't have a good water supply and don't have good vector control. This next one, this used to be in the same genus as Chlamydia trachomatis, but it's different enough that they created their own genus. So this is Chlamydiophilia pneumoniae, and this, along with the Mycoplasma pneumoniae, is one of the causes of atypical pneumonia. Next up, the spirochetes. The spirochetes all form flexible helical cells, as you can see from these micrographs. They also have, if you remember clear back to the chapter that talked about prokaryotic cell structure, they have endoflagella. They have a sheath, and you can kind of see the endoflagella that's underneath the sheath. These flagella turning the whole cell in a spiral fashion through their environment. Now, there are two different types of spirochetes that I want you to be familiar with. Treponema pallidum causes syphilis, which, although it comes after chlamydia and causing sexually transmitted disease, syphilis is still a problem, and especially since some forms of Treponema pallidum have become antibiotic resistant. Borrelia burgdorferi is a relative of Treponema pallidum, and it causes Lyme disease. This is a new and emerging disease. We didn't know about it until fairly recently, and we're becoming more and more aware of this disease. Now, you may remember that it's passed by ticks, so this is one of the major reasons that after you go hiking or go camping, you want to check yourself for ticks, because they have a tendency to go into latency. They hide out in the body without causing signs or symptoms, replicating, and when you develop signs and symptoms after that, they're worse. And the longer you have the organism, the harder it is to treat. So make sure you check yourself for ticks. Also, wear insect repellent and take other tick precautions. On to the Bacteroides. Now, Bacteroides, in the book, talks about how they live in lots of different environments, but I want to talk about the Bacteroides that live in your gut. Bacteroides are one of what is becoming known in the literature as old friends. These are helpful bacteria that we're finding out that we really need. In fact, with the genus Bacteroides, we're finding that after you're born, you don't have any bacteria on or in you, but shortly after you're born, you start picking up bacteria from your family members, especially your mother. Bacteroides is one of these, and when they colonize your intestinal tract, they chat with your intestinal mucosa cells, and they cause your intestinal mucosa cells to produce more blood vessels so that they take up more nutrients. In return, the intestinal mucosa cells release antibacterials that favor the Bacteroides. So it's all good. We're friends. Now, the book does talk about how Bacteroides is one of the more common causes of anaerobic bacterial infections in humans. They are obligate anaerobes, and if they get outside of the gut, they do cause problems. That can be said for all of your old friends that are on you and in you. If your appendix bursts, if you have a puncture wound through the stomach, either from knife wound or being shot or whatever, Bacteroides can get into your tissues and cause real problems. But does that mean that we have to think that they're bad all the time? No, they're your old friends. They just got to stay where they're supposed to. So here is a summary of the gram-negative bacteria, since we already covered the gram-positive bacteria in a summary earlier. And here are reminders of what the learning objectives for this topic are.